There are about 350 million people, accounting for 6 to 8% of the populations, suffer from color blindness in the world. Colorblind patients may have normal vision, being able to see street name signs and coming cars, but have trouble in walking or driving because they cannot distinguish the colors of traffic lights. The disability of color recognition makes them just like blind men on the road. To solve this problem, I came up with an idea designing a traffic assistant for people with color blindness. First of all, let's talk about what is color blindness. If you have color blindness, it means that you see color differently than most people. It may be hard for you to tell the difference between certain colors and how bright colors are. Color blindness is an inherited problem that the functionality of cone cells in the retina was not developed normally. Since the genes that pass down this symptom are on the X chromosome, males are much more likely to be at risk for color blindness than females. In fact, 1 in every 12 men, while there are only 1 in every 200 women, are colorblind. Based on affected cone, color blindness can be classified into 2 major types: red-green color blindness and blue-yellow color blindness. People with red-green color blindness, also known as daltonism, are often confused between red, brown, green, and yellow. It includes protanopely, possessing anonymous red sensing cone, protanopia, lacking red sensing cone, deuteranopely, possessing anonymous green sensing cone, and deuteranopia, lacking green sensing cone. Meanwhile, people with blue-yellow color blindness can hardly discern between bluish and greenish hues, such as blue and green, purple and red, or yellow and pink. It includes tritananomaly, possessing anonymous blue sensing cone, and tritanopia, lacking blue sensing cone. In a real-life circumstance, the green traffic lights in Taiwan actually contained a few blue brightness in them, so some of the colorblind are able to pass the color identification test and get license. However, it only works for the deuteranomaly patients. In some countries, colorblind overcome the challenge of distinguish the traffic lights by memorizing the position of lights. Yet the horizontal lights will differ depending on the region. Not to mention the brake lights, railway signal, and blinkers on the vehicle. Thus, for people with color blindness, driving on the road still has many inconveniences, and there are many countries refuse to grant driver's license to them until now. To invent a traffic assistance for people with color blindness, we need a receiver so that the information on the road can be inputted. A head with micro camera will be a good choice. In this way, the direction of the camera will be toward the road just like a human eye, and the electronic components can be easily hidden inside the head's brim. In addition, a returning system that shows the data processing results to the user is also needed. Since the pedestrian's sense of sight show concentrates on the road, the only way for them to get the information of the device may be their ears. The receiver, which is the camera, can transmit the data to user's phone, and through the mobile app, the analyzed road's information will be told to the user by a pair of earphones. And now we have to think about how the mobile app operates. After getting the image input by the lens, there are 2 challenges to overcome: recognizing the traffic lights and pick out the traffic lights that user come across at that time. And finally, tell the user what light is shining right now. That is to say, the app should include both image classification and object detection, these 2 functions. Convolutional neural network can be used to complete the image classification. Imitating the real animal neural network, when using CNN to process complex images, it extracts partial properties of the target object and makes them a feature detector as the judgments of recognizing. In the case of identifying traffic lights, the partial properties may be 3 circles and a long stick. Photos conform to these features have high probability, including a traffic light in them. To make a feature detector of traffic lights, we need to select a huge amount of traffic lights photo. For the computer, these photos are actually in the form of matrix. Then we need to find a smaller matrix, known as the convolution kernel, which makes the photo matrix shows partial properties after its calculation. The convolution kernel is just like a collector, starting from the upper left corner of the image, from left to right, from top to bottom, multiplying the pixel value in the scanning area with the element's value as the corresponding position on the convolution kernel. The sum of these data will be sequentially placed in a new matrix called feature map. The position with higher value on the feature map is more likely to show that partial property. By training the CNN model of optimizing its convolution kernel, it is possible for us to develop a system that could classify images with traffic lights. As for object detection, the most intuitive idea is to use a sliding window, moving constantly across the photo and record it as long as recognizing an object. However, this method is way too slow. We may need many different sizes of the sliding window in case it cannot exactly frame the object. And the computer needs to take much time recognizing this image. As a mobile device, its calculating has to be fast. Thus, there is a different way to frame where the object locates. Region proposal. Region proposal will first divide the image into many blocks according to the color. Adjacent parts with similar colors will be divided into the same block. In this way, the computer only needs to identify the segmental image of its different blocks, which greatly reduces the calculating time. If several segments are judged to have the partial properties, it will draw a rectangle, which is called bounding box, framing their outlines. By examining bounding boxes' similarity to traffic lights through CNN model, we are able to recognize traffic lights and know their exact position, identifying the nearest one and tell the user which lights it is shining. As long as the app was developed, the only cost user needs to pay for this device is the hat with micro camera. People can approach this device in a low price, and anyone with a smartphone can easily use it. Although there is currently no cure for color blindness, colorblind individuals are still able to walk on the road safely.